everybody. So in this video, I'm going to be talking about the three periodic trends: atomic radius, ionization energy, and electronegativity. You can be following along on your own periodic tables as you watch this video, or you could just be paying attention. So the first thing when thinking about the trends that you want to think about is the definition of each of them. Atomic radius is just talking about the size of the different atoms of different elements on the periodic table. Ionization energy is the energy required in order to remove an electron from an atom. Now, energy is required to remove an electron because just like a magnet can stick to a refrigerator or to a chalkboard like this one here, it takes energy in order to pull the magnet off. Just like in an atom, you have the positive nucleus and the negative electron that feels attraction toward that nucleus. So it's going to require energy to pull that electron away in chemical bonding, and that is ionization energy. If it's easy to remove an electron, something is going to have a low ionization energy. If it's more difficult to remove an electron, then something will have a high ionization energy. And then the last trend that we're going to talk about is electronegativity. And electronegativity is the tendency of an atom to attract electrons toward it when it's in a compound. So that'll be the third one that we talk about. So as we move down a group on the periodic table, you can see here, these are some group 1 elements that I've drawn out. And as we move down a group, you can see that the number of energy levels increases dependent on which period we're in. So I've drawn out a hydrogen atom, a lithium atom, and a sodium atom here. Also, a very important thing to note is that each of these have the same number of valence electrons. That's why they behave similarly. So they have the same number of valence electrons, but what is changing as you move down a group on the periodic table is the number of energy levels being filled. So for hydrogen, we see that there's only one energy level because it's in period 1. For helium, it has 2 energy levels because it's in period 2. And sodium has 3 because it's in period 3, or that's why it's in period 3. So the trend here, you should be able to see pretty quickly for size, is that as you go down this group, size increases. And the reason that the size is increasing is because more energy levels are being filled and higher energy levels are further from the nucleus, have electrons that travel further out from the nucleus. So as you go down a group on the periodic table, atomic radius is going to increase because there are more energy levels being filled and they fill further from the nucleus, making the atom bigger. Now, for atomic radius as you move across a period on the periodic table, so this is an example using period 2 elements. In period 2 elements, because they're all in period 2 or row 2, all of them have 2 energy levels. But what's changing is the number of protons in the nucleus as you move across the period, a period on the periodic table. So it's the same number of energy levels, but there are more protons in the nucleus. And right away, you should be able to see the trend in size. As we move across a period on the periodic table, atomic radius decreases. And the reason for that is there's no change in the number of energy levels, but there are more protons in the nucleus. And the more protons that you have in the nucleus, the stronger nuclear charge there is, and then that nucleus holds everything in a little bit more tightly. So it pulls everything in closer and the atomic radius decreases. Next, we'll talk about ionization energy. As we go down a group on the periodic table, well, first, before I even talk about the trend, let's remind ourselves of the definition. So ionization energy is the energy required to remove an electron from an atom. If it's easy to remove an electron, then ionization energy decreases. If that electron is held very tightly, then it's going to take more energy and it has a high ionization energy. So as you go down a group on the periodic table, ionization energy will decrease. And the reason that ionization energy decreases is you have more energy levels being filled. Your outermost electrons are further from the nucleus. Therefore, because of that distance and all these inner energy levels being filled, it blocks the nuclear charge from being felt, and they're held more loosely in the larger atoms. So it makes it easier to remove the electron from it. So the more energy levels an atom has, the easier it is to remove an electron because it's further from the nucleus. This happens as we go down a group on the periodic table. When we go across a period on the periodic table, so across the period this way, your number of energy levels is not changing, but you do have more protons in the nucleus. More protons in the nucleus creates a stronger hold on all those electrons, and it's going to be harder to remove them. So as you go across a period on the periodic table, ionization energy will increase because more protons in the nucleus causes a stronger nuclear charge and a tighter hold on those electrons, so it's going to require more energy to take them away. The last trend that we're going to talk about is electronegativity. Electronegativity is the tendency of an atom to attract electrons toward itself when in a compound. So it's the attractiveness of an atom. How likely is it that an electron is going to want to move from one atom toward a different nucleus? So as you go down a group on the periodic table, and you can see it over here on the right, electronegativity decreases. And the reason that electronegativity or attractiveness decreases is because as you go down a group, there are more and more energy levels being filled. Those energy levels filled with electrons shield the nuclear charge from being felt, and therefore it doesn't have a very strong nuclear charge or attraction toward outside electrons. So as you go down a group on the periodic table, electronegativity decreases because the nuclear charge is decreasing due to more energy levels being filled. As you go across a period on the periodic table, hopefully you see this right away, electronegativity increases because there are more protons in the nucleus, creating a stronger nuclear charge. It not only pulls electrons within the parent atom toward the nucleus more, it's also more attractive for other electrons to move toward it too. And so they do. So as you go across a period on the periodic table, electronegativity increases. Now I'm going to explain it in a way where I'm going to just explain it all in terms of atomic radius. So we're going to stay on, we'll stay on this screen for a minute and I'll explain all of them together. So as you go down a group on the periodic table, the radius of each of the atoms increase because there are more and more energy levels being filled and they fill further from the nucleus. This also explains ionization energy and electronegativity, because as you go down a group on the periodic table, because of the distance the nucleus is from the outermost electron, because there's more distance, the nucleus holds on to that electron a little bit more loosely and it's going to be easier to remove. So ionization energy decreases as you go down a group. Now, for the same reason that this electron is easier to remove, electronegativity is also lower as well. because you have all these energy levels filled with electron that shield that nuclear charge, and therefore the bigger atoms are not as attractive. Now, if we consider across a period on the periodic table, you have more protons in the nucleus, causing a stronger nuclear charge, and the size of the atom decreases because that stronger nuclear charge pulls everything closer together. Now, if it's holding everything more tightly, then it's going to require a higher ionization energy in order to remove an outermost electron from atoms on the right-hand side of the table. So it's going to have a high ionization energy as you move across a period on the periodic table. And along with that, for electronegativity, because of more protons in the nucleus, it creates a stronger nuclear charge, not only for the electrons in the parent atom, but also any electrons from other atoms will feel more of an attraction toward the elements on the right-hand side of the table as well. If you have any questions about any of these, please let me know, but hopefully this help clears up any questions on the trends. Have a good day.